Around the world, largely unseen, countless pathogens march to battle. Dangerous fungi, parasitic worms, elusive viruses, deadly bacteria. These foreign invaders constantly attack us in an all-out war. But we animals enlist an equally powerful army, equipped with weapons to defend against the assault, eager to engage the enemy in chemical warfare or hand-to-hand combat. Sometimes this army fails us, but most often it performs with remarkable effectiveness, killing thousands of pathogens each day. We owe our lives to the immune system. All animals can defend themselves against disease, but sometimes they need a helping hand.
Hi, Doc. How you doing? Hi, Brian. Got another one for you.
Veterinarian Scott Weldy treats injured birds of prey, such as owls, eagles, and hawks.
That left one's really not working too well.
Orange County Bird of Prey Center is a nonprofit corporation that deals with injured birds of prey, which are raptors. We rehabilitate after repairing injuries and then release those birds after a certain amount of exercising period back into the wild. Most of our birds are injured from, depending on the season, either man-made objects such as bullets hitting them hitting windshields or cars, or hitting wires or buildings. I just go through and do physical exam on them. I look for blood, I look for bruising, I look for swelling, I look for broken bones. And you also look at the attitude of the bird. And these guys are going to come in, they've never been held, and they're supposed to be wild and mean, and so they should have that fire in their eye. And if they don't have fire in their eye, then there's something else more serious going on.
These injuries often breach the body's surface, our first line of defense against dangerous pathogens.
The first line of defense is really that. It's the protection of the body. The largest organ of the body, most people don't realize, is the skin.
Skin or intact surfaces, those are either covered with hair or fur or feathers, and those also provide a second barrier that's on top.
Now, the skin protects what we think of as the outside of the body, and there's a special lining called a mucosa that runs through. And all of the, what we think of as the inner surfaces of the body are covered with this mucosal lining. There are secretions on virtually all of the inner mucosal surfaces. And what these tend to do is either physically wash away at some of these invaders before they can get through, or in many cases, they have molecules which actually kill them. Around the eyes, for example, tears are a protective device.
We also have cilia, which are fine hair-like projections that in certain areas of your respiratory tract, they will actually act like an escalator, transferring particles up, and so you can cough them out.
While all animals have surface barriers, some present a weaker defense than others. Dr. Weldy has observed that birds are especially vulnerable to injury.
Part of the reason I think that you see such drastic responses to tissue damage in birds is because they have very thin skin. They are also very compact, and they don't have a lot of muscle mass in them. They're not big muscled animals. So a trauma is not absorbed by their muscle mass.
An injury to the body's outer defenses calls our immune system to action in a process called inflammation.
under both the skin and the mucosal lining, there are a series of cells, which have been known for a very, very long time, called mast cells. And these cells are filled with granules. When the trauma occurs, these granules explode and the molecules come out.
These molecules cause the cells of neighboring blood vessels to expand. This, in turn, creates gaps that allow fluid to escape from the blood and into surrounding tissue.
And then it starts swelling. You get something called edema, swelling. And that's the blood fluid, not the cells, but the fluid that comes out into the local area. And that fluid from part of the blood also contains molecules which, when they're inside the blood, are inactive, but when they're outside, they become activated, and some of these can actually kill the bacteria at the site.
These molecules, called complement proteins, also attract the frontline soldiers of our immune system, the white blood cells. Crawling out through the gaps in the blood vessels, the white blood cells begin their attack.
And the first one are called neutrophils. The important part about these cells is they're short-lived, they're modal, they can move around, and they are phagocytic. They can ingest any bacteria, actually eat them at the site. They can do this reasonably well on their own, but they do it much better with some of those molecules of the fluid that came out before. So that there's this incredibly complex dance going on.
Soon the neutrophils are joined by different white blood cells, including macrophages, or big eaters. In concert with complement proteins, these cells battle the enemy until the body repairs itself. While inflammation in most complex animals proceeds in the same basic way, it's no guarantee of recovery. At the Bird of Prey Center, Dr. Weldy is especially concerned with the repair of a broken bone.
Because you're dealing with traumas that can be eventually life-threatening to these birds, because a bird of prey that doesn't hunt is going to die. When I initially receive a bird, I will put him in a smaller cage. That allows me to do a couple things. One, he's one-on-one with me, so I can monitor response to treatment, also monitor food intake. Once I notice clinically that it looks good, the bird looks like he's in good enough shape, and his ability to compete and eat is reasonable, then I will put that bird back into a flight cage. It is the end of a chapter or a book when you release one. The romantic side, the humanity side of me says that I'm finally getting him back out in the wild where that's where he belongs.
Dr. Weldy's winged patients rely on the process of inflammation to survive. But if this line of defense fails, the immune system activates its most elite troops, each designed to combat a specific type of invader.
I was growing up in the suburbs of Chicago and in camp, and we were drinking, some of the kids drank well water. And the well water was contaminated with polio. And at that time, nobody knew what polio was yet. And then I woke up one night, and I couldn't use my right leg. And within a few hours, I couldn't use my left leg. And within 24 hours, I couldn't move my arms, and I couldn't close my eyes, and I couldn't breathe well.
In the early 1950s, young Jeff Galpin almost died in one of the world's most notorious epidemics. The disease was polio, at the time a deadly viral infection without a known cure.
In that era, television and radio every day in Chicago would talk about the temperature, the pollen count, and how many kids came down with polio that day, because that was the way the epidemic went. Polio was something where they took away all my toys and burned them, because they didn't know if they carried the virus. They had me in quarantine, and they wouldn't let parents come in.
Dr. Galpin's physicians told him he might not survive the disease.
How are you? Good, good. You know? Not bad. It's been a long day. How you been feeling? Pretty good.
For today, as a
Good.
clinical researcher, he fights on to save others from another deadly virus, HIV, the agent of AIDS.
Today, instead of 4 shots, we only have to do 2 of the shoulders. Basically, HIV is unique in that it attacks not the body, which like the lung or the heart or the brain, but it's almost always, it is attacking what is called a CD4 helper cell.
Helper cells are just one in a special team of white blood cells, each of which performs different roles in the body's immune army. These microscopic soldiers spend most of their lives camped out in the nodes of the body's lymphatic system.
Now, a lymph node is a collection of a new kind of cell. The cells of the specific part of the immune system are called lymphocytes. There are a couple of different kinds of lymphocytes. The cell that we're interested in at the moment, in that lymph node, is something called a T cell.
T cells get their name from another part of the lymphatic system, the thymus gland, a kind of cellular boot camp that prepares these lymphocytes to face specific enemy invaders.
Those CD4 T cells are part of a specific immunity. They will only react with very, very unique things. And each T cell will react with something different than the next T cell.
T cells target their specific pathogens in a process known as cell-mediated immunity.
White blood cells, called macrophages, lead the body's cell-mediated immune response by engulfing and digesting foreign invaders. Combining peptide fragments from the invaders with some of its own proteins, the macrophage builds a patchwork of antigen complexes on its surface.
The proteins of anything, the bacteria, virus, parasite, anything that they're ingesting, those proteins only get broken down partway. They get broken down into chunks. And these peptides get loaded inside of a molecule that's made inside of the macrophage. We abbreviate it by calling it MHC. And each one picks up, just at random, one of these peptides. And they get moved up to the surface of the macrophage.
When smaller white blood cells, called helper T cells, encounter the macrophage, those with matching receptors bind to its surface. These helpers then multiply and secrete chemicals which call different cells into battle, especially the cytotoxic or killer T cells. The macrophage, or an infected cell, activates only those cytotoxic cells with receptors that match the antigen complexes. Stimulated by chemicals from the helper T cells, these killer T cells rapidly divide into an army of clones, all designed to fight the specific invader that triggered the response. When killer cells dock with an infected cell, they bombard it with lethal toxins, then move on in search of other targets.
So that on average, hundreds of thousands, of millions of lymphocytes, of T cells, in that lymph node, each of them has gazillions of receptors, but each of them has unique and different receptors. And that's where the specificity of the immune response comes from.
By targeting CD4 helper T cells, HIV attacks the very arsenal we use to defend against it.
And so what we see in HIV disease is the effect of having less CD4s, not the effect of having HIV. It isn't the virus which causes the diseases that we see on the whole. It is the effect of the virus on our immunity, which then makes the individual susceptible. They die of the things we all walk around with and carry all our lives, because the CD4s become deficient.
CD4 T cells also play a key role in another type of immune response called humoral immunity, because it releases products into body fluids once called humors.
And what has evolved is another molecule from the immune system made by another kind of lymphocyte, and these are called B cells. B cells have receptors on their surface, but these receptors are a little bit different than the receptors on the T cells. They reside on the surface, but they can leave the surface. They can be exported, and they're antibody molecules when they're exported.
And antibodies have a couple of branches. At the ends of those are a set of sequences of amino acids and peptides that exactly match the mirror image of some protein.
The body's humoral, or antibody-mediated immune response, begins in the same manner as its cell-mediated response. But here, the macrophages are joined by lymphocytes, called B cells. The pathogen activates only those B cells with matching receptors. These cells stand ready to enter the battle. Meanwhile, the antigen-presenting macrophages activate those helper T cells with matching receptors. These, in turn, rendezvous with activated B cells. Triggered by this meeting, the helpers release chemicals which spur the selected B cells into rapid reproduction. Some B cells become memory cells, ready to respond to a later invasion by the same pathogen. But most become antibody-producing factories, called plasma cells. Freely circulating in the body, antibodies dock with pathogens. This neutralizes them, or marks them for destruction by other weapons in our immune arsenal.
The macrophages, which I've already mentioned, will see the antibodies and say, aha, anything that's coated with these antibodies is fair game for lunch. That's one way to get rid of the foreign elements, cancer cells, and bad viruses and bad bacteria.
Understanding how the body produces antibodies has allowed scientists to develop vaccines, such as those which stop the scourge of polio. Vaccines contain antigens of a particular disease agent. The body responds by actively producing the appropriate antibodies and memory cells. Unfortunately, vaccines have proven ineffective against the AIDS virus.
HIV has the ability to be an RNA virus, get into a cell and turn into a DNA virus, which can become part of our genetic material, sit there, and then come out again as an RNA virus. That allows it to cloak itself, to hide from parts of our immunity, to sit within a cell so that the antibodies that are outside of the cell can't do anything.
In response, Dr. Galpin and his colleagues are exploring other methods of treatment, including genetic engineering.
Start timing.
30.
For research only, we've tried to take a piece of the virus, put the piece of HIV in another virus, and then put it back in the body so that the body would now see it better and turn on the cellular immune system to better recognize HIV and go out and kill it.
A quiet war wages within us at all times. We become aware of it only when our immune system starts to lose the battle, whether from doing too little or doing too much. As the happy mother of the bride, Carolyn may seem the picture of health. But inside her body, a battle is raging. Carolyn suffers from lupus, a life-threatening autoimmune disease.
With lupus, we have overactive immune systems. It's the antibodies in our blood that are overactive. So instead of protecting our body the way they're meant to, we're allergic to our cells. They attack us.
An autoimmune disease is where, whether it's an animal or in a human, what should be looked at as self and not attacked is looked at as foreign, and the body starts making antibodies against itself. The most common of these conditions is something called rheumatoid arthritis. There are then more generalized autoimmune diseases like systemic lupus, where a person makes antibodies against many different organs.
Hi, Carolyn. Good to see you. More than 1 million Americans suffer from this disease in which antibodies cause chronic inflammation. Untreated, lupus can lead to serious organ damage, even death.
When you wake up in the morning, have you felt restored? So depending on the target organ of the antibodies, that is what determines what type of lupus a person can have. But it can be very mild with antibodies against only the skin, only against the lining of the heart, or very severe with antibodies against the kidneys or against the brain, where you can go into a coma or have kidney failure.
Doctors found that Carolyn suffers from a special kind of lupus that attacks the white blood cells of her immune system.
Normally, we have about 4,000 white blood cells, and her white blood cell count was 2,500, which made her feel very tired with having these low white cell count. And subsequently, Carolyn started developing the other symptoms that we see with lupus. Her joints became swollen, her muscles became weak.
These are especially swollen.
The other problem with lupus is that it can be visible disease. So oftentimes the chief complaint is, I feel terrible when I get too hot or out in the sun, and I'm tired all the time. And the doctor will look at the patient and say, well, you look fine.
Now, does that hurt to do that? No. Okay. Not only is lupus difficult to diagnose, its cause remains a mystery. Current research points to a problem with protein complexes displayed on the surface of body cells.
There are these markers called MHC, and MHC stands for Major Histocompatibility Complex. These MHC markers that are expressed on the cell surfaces are what the body gets used to seeing as either being self or foreign, because each individual has their own identical MHC marker.
Researchers theorize that some victims of autoimmunity may be producing abnormal MHC complexes, which the immune system identifies as foreign.
We can now find in people who have a hereditary predisposition to these autoimmune diseases where this MHC coding is found, and have been able to take this area and determine certain of these antibodies that are formed. But what we don't know is why everyone who has this genetic makeup does not end up having these autoimmune diseases.
In addition to these genetic accidents, researchers believe some autoimmune diseases may be caused by abnormal white blood cells. Some of these may slip through the body's thymus gland, which normally destroys those killer T cells that would attack healthy tissue.
The hypothesis is that one reason people develop an autoimmune response is because these T cells that are supposed to be destroyed in the thymus are not. So you have circulating T cells that recognize self as being foreign. There's also hormone triggers with systemic lupus. In lupus patients, we have 9 women to 1 male. Usually lupus develops where there are times of hormone fluxes, around the time a woman develops their first menstrual period, or during or after a pregnancy, or at the time of menopause.
Let's go over your list of medicines and make sure we've got everything right. Are you still taking the... Doctors can now treat the symptoms of this immune response with a combination of medications that reduce inflammation. What about your eyes? No, don't look too dry. Okay.
Carolyn right now is doing fairly well. She's been under a lot of stress lately, and so that her white count has started to drop down. She's had more fatigue.
That's my biggest problem is the fatigue and pain, but I'm under quite a few medications, and I feel my doctor and I have it under pretty good control.
While recent advancements in treatment are helping those who suffer from lupus, a cure remains just out of reach.
What determines the severity of the disease? Why does one person who have very mild disease with rash and arthritis and someone else die of kidney failure? We really have so many questions about these diseases. And the more we find out about the immune system and find out how complex it is, we realize how much we really don't know.
Thankfully, our immune system is as effective as it is mysterious. Able to fight off all but the most persistent and insidious invaders. As we explore the intricate mechanisms of this organ system, we continue to depend on its complex army of defenders. Our champions against the perils of the outside world.